All right, so just a little bit ago, we talked about vertical and horizontal shifts. Okay, so remember that a vertical shift happens when we add or subtract a number or a positive number to the end of a function. And a horizontal shift happens when we add that number to the inside of our of our function. Now we're going to talk about what happens when we multiply the outside or the inside of our function by some number. Okay, these are called vertical and horizontal compressions. Okay, to be a vertical compression or a vertical stretch, let's focus on this graph y equals f of x. Okay, if it's going to be affecting this vertically, so how far up and how far down this graph is going to go, we're going to multiply the outside of our function by the some term. So we're multiplying every term inside of our function by a single value or a single value of a. Okay, so it says that if a is between 0 and 1, in other words, it's a fraction and it's a fraction that's less than 1, then the new graph is vertically compressed. Okay, so in other words, it's taking the graph and it's making it shorter. Okay, then if a is greater than 1, then our graph is vertically stretched. Okay, in other words, it's making it longer. So again, just kind of taking a look at maybe what this looks like. If I have my original function, so let's say it's a parabola, okay, and I had an a value in front of the x values, or in front of all the values, that was less than 1 but greater than 0, what it's going to do is it's going to make this graph flatter. Okay, so it's going to flatten the graph. Whereas if my a is bigger than 1, it's going to make my graph taller. Okay, so every x value or every y value shifts upward by a factor of a. Okay, so I'm going to go ahead and actually take a look at this first example, and we're going to use those rules. I'm going to go ahead and we'll do purple for this. Okay, so notice that I'm taking my function. Okay, this is the representation of the function down here. So this is f of x right now. Okay, and it's saying that we're doing a vertical stretch of a factor of 2. Okay, so this is a vertical stretch of a factor of 2. So in other words, any y value that I'm dealing with, I'm going to multiply that y value by 2. Okay, so let's take a look at this first unit. Okay, notice that that first dot is at y equals 0. Okay, it's on my x-axis. Okay, so it means that it's at y equals 0. So y equals 0. If I multiply 0 by 2, so if I multiply by 2, I still get 0. So I can actually put my first dot right there. Okay. Now let's take a look at the next intersection that we can kind of take a look at. So let's take a look at this point here. Okay, we need to kind of identify what our y value is here. So this one, our y value is actually 1. If we multiply 1 by 2, we get 2. So it's not changing this in either x direction. It's only changing this vertically. So we get y equals, that our new y is equal to 2. So I'm actually going to put a dot directly above it at 2. Okay. Then I'm going to take a look at this next intersection. So at pi. Okay, at pi, if we multiply our y value by 2, we still get 0. So I'm going to put a 0, put a dot at 0. Then I'm going to take a look at this next one. Okay, so right here, this one is y equals -1. If I multiply -1 by 2, I get -2. So right there. And it kind of repeats this pattern. So this is actually a trigonometric function. It's one that if you do get into geometry, it's very common. And these transformations happen a lot, but this is a good kind of overview on what this looks like. Okay, and we're going to do that for each of these kind of peaks and valleys. Okay, and we're just going to kind of change it. So now when we draw it, notice that my graph has shifted. It hasn't shifted at all. It's stretched vertically. Okay, so it's kind of like taking a slinky and pulling down on either side. Okay. All right, so now let's talk about a horizontal compression and a horizontal stretch. So when I multiply my x value, so notice that here I was multiplying my entire function by a. Now I'm multiplying just the x values by a, okay? When I do this, we can get the new function by multiplying each of our x values by 1 over a. Okay, so we're going to multiply each of our x values. So multiply x values by 1 over a. Okay? If a is greater than 1, then it's a horizontal compression. So it's taking our graph and it's shortening it. So like if I'm looking at this graph over here, and let's say I've had a was 3, okay, it would take that graph and it would actually shorten it by a factor of 3. Okay, so it'd make it, actually we're going to be doing that here in just a second. I'll show you guys what that looks like here in just a sec. Okay. If a is between 0 and 1, it's a horizontal stretch, so it's making it longer. So think of a compression, a horizontal compression, as pushing a spring together, where a horizontal stretch is like pulling a spring apart. Okay, so this is kind of backwards from the vertical and horizontal, the vertical compressions and stretches, and the fact that it gets longer if it's between 0 and 1, and it gets shorter if it's greater than 1. Okay, so let's go ahead and take a look at this this next part of the example. Okay, so notice that we have our a is greater than 1. Okay, it says the function is horizontally compressed if this is the case. Okay, so again, we're just going to kind of focus in on, so again, a is 3. Okay, we're going to focus in on this time. Remember, it multiplies the x values by 1 over a. So we're going to multiply each of our x values. We're just focused on we're still looking at the peaks, but we're focused on those x values. We're going to multiply it by 1 over a. So 1 over a is actually just 1/3. So we're multiplying each of our x values by 1/3. It doesn't change this vertically at all. It's going to just change the horizontal. So taking a look at this one, the first point, okay, notice that my x value is 0. So if I multiply x equals 0 by 1/3, we still get 0. So I can actually start my graph at 0, okay? Next, I'm going to take a look at this point here. Okay, so again, we're just multiplying our x values by 1/3. So my x value here is pi over 2. So pi over 2 times 1/3 is actually just pi over 6. So 1/6 of pi. Okay, so here's pi over 4. 1/6 pi would be somewhere in here. It's not changing this horizontally. I'm just going to kind of estimate about where it should be. Okay, so I know that it's less than 1/4, so I'm going to put it about right there. Okay, so we've just shifted this essentially to the left by a factor of 1/3. Okay, now I'm going to look at the next intersection. The next intersection is pi. Okay, so I multiply pi by 1/3, and I get pi over 3. Okay, pi over 3 is between pi over 4 and pi over 2, so it'd be, I'm going to go ahead and say somewhere right in here. Okay, then I'm going to look at this next peak, so the next peak would be over here at 3 pi over 2, so 3 pi over 2 times 1/3. Those cancel out, and we're left with pi over 2. Okay, and I actually do have a point pi over 2, so I can leave that here. So notice again, we're not making this taller, we're just making, this is a compression, this is a horizontal compression. Okay, and I'm just going to do this for each of the other ones. So this would be pi over 2 times 1/3, which is 2 pi over 3. So I would say that that's about right here. And then the last, we have 2 more points. So this one would be 5 pi over 2. So that'd be 5 pi over 6. So I'd say that's about right here. And then finally, we have 3 pi times 1/3 would be just pi. So that would be this point here. And then I can trace through my graph. Okay, so this took our spring and it really compressed it down. okay? All right. So now let's take a look at reflections. So a reflection, if it's a reflection across the x-axis, we're changing the y values. Okay, if it's a reflection about the y-axis, it's changing the x value. So it's changing the sign in front. We've done this already. Okay, in whenever we were checking for reflections about the x and y axis and checking for symmetry. This is very similar. It's just when we're now using this in order to actually graph this. Okay. So I want to take a look at this example. It says, find the function that is finally graphed. We're not actually going to be graphing this. After the following three transformations are applied to the graph of y equals absolute value of x. Okay, so we're going to be just basically transforming this as we go. So this is a shift left. So number one says shift left 2 units. So remember that shifting left or right, you're adding to the inside of the function. The inside of the function is the inside of our absolute value in this case. Okay, so step one, a shift left 2 units. Remember that the inside is your is opposite of what you would think. So left is actually plus, so this is going to be x plus 2. Okay. Step 2 is a shift up 3 units. So this one you're adding to the outside of the function. All right. So in this case, I'm going to take my new function in step 1, and I'm going to add 3 to the outside. And then finally, a reflection about the y-axis is, okay, so a reflection about the y-axis, you're changing all of your x values from positive to negative. Okay, so this would be y equals absolute value of negative x plus 2 plus 3. Okay, if this were a reflection about the x-axis, you would stick the negative on the outside of your function. Okay, but this is a reflection about the y-axis, so it's on the inside attached to your x. And this is the final function, oops. This is the final function that we get out. All right. So these last two examples, we are going to be asked to graph the function. Now, this looks overly complicated, but if we were to take away all of the transformations, we can actually get a sense of what this function should look like. Okay, so the first thing I'm going to do is I'm going to take away this plus 1. You don't have to do this on your paper. I just kind of want to show you what's happening. Then I would take away the minus 2. So I like to take away the addition and subtraction first. And then I'm going to take away any other number. Just make sure that if it's multiplied, so this would be, you're actually multiplying by 3. Okay, so make sure that if it is a multiplication, you're replacing that with a 1. Okay, so our original function is actually f of x is equal to 1 over x. Okay, now I have asked you guys to graph this before, and I'm going to do that for you now. So knowing these functions, knowing what these look like is going to be really, really important. So this actually has what's known as an asymptote. Okay, it has an asymptote at 0. An asymptote is a section in which they cannot cross. Okay, so notice that x cannot be 0. Okay, so x can't be 0 in this first function, and so that's going to be the asymptote. All right, so this graph goes through the point 1, 1 and negative 1, 1. Okay, and then it's just going to kind of do this thing here. So it's going to get really, really close to the y-axis, and it's going to go down, and it's going to get really, really close to the x-axis. Okay, and it's going to do the same thing here. So it's going to start really, really close to the x-axis, get close, and it's going to get really, really close to the y-axis. Okay, so this is symmetric about the origin. All right, so now let's take a look at what each of these transformations do. I'm going to save the 3 for last. Okay, so let's take a look at the bottom here. Okay, so we're subtracting 2 from the x value. So this is a horizontal shift. Okay, and if we're subtracting 2, it's a horizontal shift to the right that many units. Okay, so we're subtracting 2, so we're going to be going right 2 units. okay? Then we shifted up 1 unit, okay? So we shift up 1, and then we're going to compress this by a factor of 3. Sorry, we're going to stretch this by a factor of 3, okay? So let's take a look at what that means. All right, so I'm going to leave this in blue. We're going to shift our point to the right 2 units. So each of these points, I'm going to shift right 1, 2 units. I'm going to put a dot. I'm going to go 1, 2 units. I'm going to put a dot. Okay, remember that there's this imaginary line that these can't cross through, so it's actually shifting it to the right 2 units as well, okay? And it did the same thing for this, okay? So we have our new graph right here, okay? Again, we're going to cover this a little bit more in depth whenever we get into class, but this is essentially what we're doing, okay? Next, we need to shift it up 1 unit. So we're going to take it from the blue line. We're going to shift each of our points up 1 unit, and that includes these vertical and horizontal axes. Okay, and we have our graph here. Okay, and in fact, I think what we're going to do is we're just going to stop here with vertical and horizontal shifts on this one because it is a difficult graph to graph. I'd rather spend some time in class, and we'll talk more about these types of graphs. Okay, so pretend like you didn't see this one, and we will actually cover this in class.